this we can actually see if we observe over, let's say, 20 years timescales. Stop it here. So we started from the central black hole in the Milky Way galaxy, and what I tried to say while the music was playing, you saw those stars go around, and we can actually see that not on these timescales, but it takes about 20 years for the nearest stars to go all the way around. You can work out the time it takes, but also the orbits and how big the size of the orbit is, and that together gives you an indication of how massive the black hole is in the center. And as I said, that's about 3 million times as massive as our sun. Now, I showed you a picture earlier of the Milky Way being flat, with a nice disk and all that. A couple of years ago, with my PhD students in China, we worked out that the Milky Way is actually not as flat as we thought. And this is a nice animation made by our friends at Swinburne University that shows you more realistically what the Milky Way might look like. And this is interesting because it was picked up by a lot of news media, like 1,500 different media all over the world, and this was during the Chinese New Year's holiday, so none of my Chinese collaborators were available, and so a lot of media came to me, which was fun. But we even appeared in The Sun, this is our claim to fame, where the Milky Way is actually twisted, as blah blah blah, right? Scientists are pondering what this means for humanity, and at the bottom you can see here space boffins are thinking about it. Wonderful, great that this goes into the very popular press in the red tops in the UK. Absolutely fantastic. We got a lot of good media coverage there. This is not good media coverage, but we got a lot of good media coverage. So going beyond that, step 22, 10 centimeters, a million light years on the side, we see our Milky Way galaxy, and we see what we call the local group of galaxies. The Milky Way is the central galaxy of a group, several, maybe 50 galaxies or so. The Andromeda galaxy is, no, sorry, I should say that okay. There are two large galaxies, the Milky Way and the Andromeda galaxy, and a bunch of smaller ones, and the smaller ones are closer. The smaller ones are, in our case, called the Small and Large Magellanic Clouds, which are visible from the southern hemisphere. You can see them with your naked eye in a dark area, but you shouldn't look at them directly. You should look at them from the side of your eye, which is more sensitive to faint radiation. So from the side of your eye, you can see them out in the Blue Mountains or whatever. This is what they look like. This is what the Large Magellanic Cloud looks like with a telescope like the Anglo-Australian telescope in Siding Springs, in Coonabarra Brown, in New South Wales. This is what the Small Magellanic Cloud looks like. The Large Magellanic Cloud is about 1/10 as large as our Milky Way, and this one is about half the size again of the large one. This is the area of my own research interest. I've been a core team member of a research team, international team, that has looked at these two galaxies in very great detail with a telescope in Chile. And this is an almost final picture of our survey, Small Magellanic Cloud and the Large Magellanic Cloud. And this next movie actually shows you how beautiful those galaxies actually are if you really zoom in, and I would like to share that with you, because it's a passion of mine to really study these objects and try to understand what we can learn. Using the VISTA telescope in Chile, which is a 4-meter diameter telescope. And this was done in what's called service mode, so it was done by local people working at the observatory that we got the data via the internet. So that's the Large Magellanic Cloud. Looking at the time, I think we're okay still. And then we're starting to zoom in soon, I think. We've got a few of these movies, so I don't remember which one I put in here. So you can see we're going now from visible light to infrared light, which we use for our survey, and you can see the intricate details that we can see with the telescope like a 4-meter diameter VISTA. Gorgeous data. We, as a team, led by my Italian colleague Mario Sacchioni at the Astrophysical Institute of Potsdam in Berlin, we have published more than 50 research papers simply on these data over the last 10 years or so. Beyond the nearest galaxies, we have Andromeda. I mentioned that earlier. Another is a cousin of the Earth. It's very similar, maybe slightly more massive. You can see the Andromeda galaxy with binoculars. Not too much from Sydney because you need to go north of the equator. But you can see it with binoculars. And I'm going to skip through here. Alright, we're getting to the edge of the universe, but there's a bunch of really cool stuff still to see. So let's go there. We're now 10 to the 23 meters on the side. That's us in the middle with a whole bunch of galaxies around us. A whole bunch of galaxies put together is called a galaxy cluster. The Milky Way, the Andromeda Galaxy, and our companions are located in the outskirts of what's called the Virgo cluster of galaxies. And I've got a fantastic animation based on real data that shows you what's out there. And we're starting from the sun. We're moving now in this animation to the Orion, the belt of Orion, near some of the nearest stars. There is the Orion Nebula is down here, which is the closest region of active star formation. Beyond that, we move to another area of active star formation. It's a nursery of stars in essence, and that's called the Horsehead Nebula, because that black patch there looks like a horse's head. That's what's called the Horsehead Nebula. We move on and we see now the remnants of a star that exploded quite some time ago. It's the Monoceros R2 supernova remnant. Stars more massive than 8 times the mass of the Sun explode at the end of their lifetimes. And they leave some debris behind, a white dwarf and things like that. And here we have another exploding star, that's the Crab supernova, which was seen with the naked eye by Chinese and Arab astronomers 1,000 years ago. When you mention that in China, they get very excited. Now in the background you see what the disk of our Milky Way galaxy is thought to look like, and all the dark stuff is that soup that you find under your bed that I talked about, right? And this is also a good representation of how dense the stars are in the Milky Way, particularly in the very center. And this will shortly move to the two Magellanic Clouds, named after Ferdinand Magellan, who was the first to circumnavigate the Earth in the 1400s. The Large Magellanic Cloud, the Small Magellanic Cloud, and everything else now you see here is a galaxy, not individual stars. The M33, the Triangulum Galaxy is about to show. That's Andromeda. That's the other large galaxy. That's the Triangulum Galaxy. It's the third largest galaxy in our local group of galaxies. Hubble Space Telescope images here. And we're going through another region of very active star formation where new stars are born today. That's Andromeda, and it's a bit for us, you should be able to see a lot of galaxies in the background. And in particular, the center of the Virgo cluster. The center of the Virgo cluster is a galaxy called Messier 87. It's an elliptical galaxy. It's featureless, looks like an ellipsoidal distribution. It's famous, I guess, because it was the subject of the first actual picture of a black hole. That was in that central galaxy in the Virgo cluster a couple of years ago, now, just before COVID. I remember it because I was on my way to China as an associate dean at Macquarie Uni. I landed in Guangzhou, and the media wanted to have a quote. And I went to the hotel, and 2 hours later they had a quote. That was before COVID. But you can see all these galaxies out there. So there's a lot to study for us astronomers, and we can learn a lot about gravity, about elements, and about all kinds of stuff. But anyway, now I showed this movie a number of years ago when I worked in the UK earlier in my career to a group of amateur astronomers. And after the talk, I went to the pub, as you do in the UK. And the following day, the secretary sent me an email and said, Richard, we were chatting about your movie in the pub, and we weren't sure whether we were going, below the speed of light or faster than the speed of light. But you can't go faster than the speed of light, right? This was 50,000 light years in 3 minutes. So yeah, we went faster than the speed of light because you can do that in the movie, right? Anyway, that was funny. Now, here's an example of some of the galaxies that are out there observed with the James Webb Space Telescope. And the James Webb looks at infrared radiation, heat radiation, so you get to see in red where all the new stars are being formed. A whole bunch more galaxies, all in red, because that's what we observe. There's a whole variety, a whole zoo of galaxies out there. beautiful. A lot of science to be done at very, very high resolution. Yes?
Question, so you talk a lot about new galaxies and new stars being born. So I know the universe is expanding, but if I just take like a snapshot of a part of the galaxy, can you say like is the galaxy aging, or can you say how old that part is?
Yes, we can.
So you can actually see the aging, even if it's a random set of stars, and you can say, look, this is.
Yeah. So what we can, there's a lot of techniques, right? What we can do is we can look at the distribution of light as a function of wavelength. That's called a color, for instance. And over time, when stars or stellar populations, groups of stars get older, they get bigger. So that can be calibrated. It's quite easy to do actually. So we can get ages, particularly of groups of stars, maybe not so much of individual stars, it's much harder. We can get ages, we can get masses, we can get chemical compositions using spectroscopy. There's a whole lot of physical parameters that we can determine based on images and spectra of.
I think my question is, are there like parts of the universe which look now like the way most of the universe looked billions of years ago?
Yes, and oh, that is an interesting question. Yes, we can see what the universe looked like billions of years ago, but then we need to look at objects close to the edge of the universe, because light from those objects has taken all that time to get to us. So we look at the early universe. I'll show you some of that as we get to the end, and there's a few more slides to go. I'll refer to it.